Welcome back to my channel Shri Statistics. Today we are going to discuss some results on characteristic roots and characteristic vectors of a matrix. So the first result states that a characteristic vector x corresponding to the characteristic root lambda of a matrix A is also a characteristic vector of every matrix f of A, where this f of a or f of x is any scalar polynomial and the corresponding root for f of a is f of lambda. In general, if gx is equal to f1x upon f2x, where this bottom the denominator is not equal to 0, then g of lambda is a characteristic root of g of a from here, and this g of a is given as f1a into f2a inverse. So if for the proof, let us consider that ax is equal to lambda x, then a square x can be written as a multiplied by ax, and replacing this ax by lambda x we get lambda into ax. Again replacing this ax by lambda x we get lambda into lambda x, that is lambda square x. Repeating this process k times, we get a raised to the power k lambda is equal to lambda k into x. So hence, suppose for this fax, we can write from the Cayley-Hamilton theorem, if you would recall, we can write this equation like this. So on opening this bracket and multiplying each term by x, then what do we get? This am can be replaced by lambda m. So on solving this one, this comes out to be a naught plus a1 lambda plus a2 lambda square and so on up till am lambda raised to the power m multiplied by x. So what is this? This is nothing but basically this equation in lambda form, which is lambda f of lambda x. Thus x is the characteristic vector of the matrix f of A, and f of lambda is the corresponding characteristic root. Since f of 2A is not equal to 0, the matrix f of 2a is non-singular, and as such no characteristic root of f of 2a is 0. In particular, f2 lambda is not equal to 0, for f2 lambda is a characteristic root of f2a. So now if we consider these two equations, the first one states that f1ax is equal to f1 lambda x, and the second one states that f2ax is equal to f2 lambda x. So from the second equation, we can write f2 lambda inverse x can be written as equal to f2a inverse x. And hence g of a can be written in this form, f1a into f2a inverse x. That can be, now replacing this again by this lambda, we get f1a into f2 lambda inverse x. So on solving this, we get f2 lambda inverse f1a. This is nothing, we are just separating these two terms from here. And then we get f2 lambda inverse into f1 lambda x. So what is this equal to? This function is equal to g lambda x. Thus x is also a characteristic vector of GA corresponding to the characteristic root g lambda. So this is all for the first characteristic. We will consider other theorems later on. If you like the video, please like, share and subscribe. Thank you for watching.